Mirrors don't flip left and right, you do. I know that sounds wrong. Stand in front of a mirror, raise your right hand, and the reflection raises its left. It seems obvious, undeniable. But I want to show you that what you're seeing is not what the mirror did, it's what your brain did. And once you see that clearly, the question stops being about optics and starts being about something much more interesting. How your mind constructs a sense of space, what chirality means in physics, and why the universe itself, at the level of subatomic particles, treats left and right differently. I'm Paul Dirac. Let's take this apart properly. Start with what a mirror actually does, physically, without any interpretation. A flat mirror obeys one rule. The angle of incidence equals the angle of reflection. Every point on your body emits and reflects light in all directions. The light that travels toward the mirror hits the surface and bounces back at a matching angle. What this means geometrically is precise. The mirror reverses the component of every light ray that's perpendicular to its surface. The axis pointing directly into the mirror, the depth axis, the front-back axis, gets reversed. Everything else is preserved. Your head is at the top in the mirror, your feet are at the bottom. Your left shoulder is, and here's the thing, on the same side in the mirror as it is in reality. If you're standing facing north and the mirror is in front of you, your left shoulder is to the west. In the reflection, your left shoulder is still to the west. The mirror didn't move it. The mirror reversed exactly one thing, depth. Front became back. Back became front. That's it. That's the complete physical description. Left, right, up, down, untouched. So where does the flip come from? It comes from you. From something your brain does automatically, without asking your permission, the moment it sees a facing human form. When you look at your reflection, your brain doesn't think there's a front-back reversed version of me. That's not how human social cognition works. Your brain sees a body facing you, and it immediately, instinctively, interprets that body the way it would interpret any body facing you, as a person who walked toward you and turned around. That mental operation, rotating a person 180 degrees around the vertical axis to bring them face to face with you, is what swaps left and right. When you turn around to face someone, your left and their left are on opposite sides. That's not a mirror effect, that's what facing means. The mirror shows you a front-back reversed image. Your brain translates that as a person who rotated to face you. And a person who rotated to face you has their left and right swapped relative to yours. The brain reports this as the mirror flipped left and right. But the mirror didn't. Your brain's social geometry did. This is not a trivial distinction. The mirror is innocent. The flip is a cognitive artifact, a consequence of the most natural interpretation your brain makes of a facing body. But now the real question. Why does the brain choose that interpretation? Why rotate around the vertical axis? Why not imagine a person who did a somersault, rotating around the horizontal axis to end up facing you? That would flip up and down, not left and right. And the answer is grounded in something simple and physical. You almost never flip upside down to face someone. That's not how bodies move. Bodies that stand upright on flat ground, that navigate a world with a consistent gravitational direction, rotate about their vertical axis constantly, turning left, turning right, spinning to face different directions. We almost never rotate about the horizontal axis to reorient. It's not a movement pattern that exists in everyday human life. So when your brain needs to interpret a facing body, to apply its model of how people reorient in space, it picks the rotation that's physically plausible, the natural one, the vertical axis rotation, and that rotation swaps left and right, preserves up and down, and generates exactly the flip you see in the mirror. The left-right flip isn't what the mirror does, it's what your motor and social cognition system based on how bodies actually move in the physical world. The mirror just provides the front-back reversal that triggers the interpretation. Here's how you can prove this to yourself. Take a mirror, a small one will do, and lay it flat on the floor. Stand over it and look straight down into it. Now what do you see? Your head appears at the bottom of the reflection, your feet at the top. Up and down are flipped. Left and right are preserved perfectly. The physics of the mirror is identical. The same law, angle of incidence equals angle of reflection, is operating in exactly the same way. Nothing about the mirror changed. What changed is the orientation. The mirror is now facing up. The axis it reverses, the front-back axis relative to the mirror surface, is now the vertical axis relative to you. So the reversal appears in the up-down direction instead. The mirror, always and only, reverses the axis pointing into it. When that axis is horizontal, as it normally is when the mirror hangs on a wall, the reversal appears in the depth direction, and your brain translates it into a left-right flip. When that axis is vertical, as when the mirror lies flat, the reversal appears as an up-down flip. Same mirror, same physics, different orientation, different apparent flip. The experiment is decisive. The mirror doesn't care about left and right as concepts. It reverses a geometric axis. You assign the human meaning. Now let's go to the writing experiment, because this is where the intuition fights back hardest. Hold a piece of text up to a mirror. The letters are reversed. B becomes D, P becomes Q, the whole line reads backward. This feels like proof that the mirror flips left and right. It feels conclusive. But trace through what actually happened step by step. The page was facing you. You rotated it to show the mirror. How did you rotate it? Almost certainly around its vertical axis. You tipped it backward, bringing the face of the page toward the mirror. That rotation, the one you performed, swapped left and right on the page. The word that read left to right for you now reads right to left for the mirror. Then the mirror reflects it, reversing front back as always, and you see reversed text. The left-right reversal happened when you rotated the page, not when the mirror reflected it. Test it differently. Hold the page above your head, face down, and tip it forward toward the mirror, rotating it around its horizontal axis instead of its vertical one. Now the text appears upside down in the mirror. Not reversed left to right, upside down, because you rotated around a different axis and the mirror faithfully reflected what you gave it. The page's front back was reversed by the mirror, as always, but since you flipped it vertically, the result appears vertical. Every time the text appears reversed, it's because of how you presented the page to the mirror. The mirror has no preference. It does the same thing every time. Now, here's where the question opens into physics that goes well beyond mirrors. Left and right, in the deep sense, connect to one of the most fundamental concepts in physics, chirality, handedness. A left hand and a right hand are mirror images of each other. They're geometrically identical in every measurement, same finger length, same angles, same proportions, but they cannot be superimposed on each other, no matter how you rotate them in three-dimensional space. To turn a left hand into a right hand in 3D, you'd have to flip it through a fourth dimension, which is not available to us. They are genuinely, irreducibly distinct objects. This chirality shows up everywhere in nature. The amino acids that make up proteins in all living organisms on Earth are almost exclusively left-handed, L-amino acids. The right-handed versions exist and can be synthesized, but life doesn't use them, with rare exceptions. Why? We don't fully know. It may trace back to conditions in the early solar system, possibly to interactions with circularly polarized light from a neutron star. The origin of biological homochirality, why life chose one hand, is an open question. But here's the deeper point, and it's one that genuinely surprised physicists when it was discovered. The universe distinguishes between left and right. In 1956, Chen-Xiang Wu performed an experiment that confirmed a theoretical prediction by Tsung-Dao Li and Chen-Ning Yang. The weak nuclear force, one of the four fundamental forces, violates parity symmetry. Parity symmetry is the idea that the laws of physics should be the same if you replace every left with right and every right with left. It's the idea that the mirror image universe should behave identically to ours. The weak force doesn't obey this. It preferentially interacts with left-handed particles. If you built a mirror image version of a radioactive decay experiment governed by the weak force, it would produce different results than the original. The universe is not symmetric under mirror reflection. Left and right are not physically equivalent at the fundamental level. This was a shock. Prior to Wu's experiment, most physicists assumed parity was a sacred symmetry, that nature had no way to distinguish a left-handed world from a right-handed one. The experiment showed otherwise. Li and Yang received the Nobel Prize. Wu, who actually ran the experiment, was passed over, which is a separate injustice worth knowing about. The point is, the mirror puzzle that seems like a trivial question about everyday optics is a surface manifestation of one of the deepest asymmetries in the physical universe. Left and right are not the same. The universe knows the difference. And here's the philosophical edge that I find most interesting. If you tried to define left to someone or some entity with no prior experience of physical reality, using only abstract language, you could not do it. You can define up by pointing to the direction gravity pulls. You can define forward by the direction of motion. But left? Left is irreducibly dependent on a physical reference. You need a chiral object, a hand, a molecule, a specific particle decay, to anchor the definition. Without a physical handed object, left and right are just labels you can swap without consequence. Before the Wu experiment, this was purely philosophical. Physicists thought maybe left and right are just conventions with no physical content beyond the assignment. The experiment showed that no, there is physical content. The weak force picks a hand. The universe picks a hand. But the conceptual difficulty of defining that hand in purely abstract terms, the fact that you need to point at something physical to distinguish left from right rather than derive it from first principles, that difficulty is real and fundamental. The mirror puzzle is the everyday version of this. The reason the mirror seems to flip left and right is precisely because left and right are not cleanly defined geometric directions the way up and down are. Up is anchored by gravity, a genuine physical asymmetry present in everyday experience. Left and right are anchored by your body's own chirality, your own handedness, and the conventions you built on top of that. Remove the body, remove the observer, and the question, which way did the mirror flip, loses its grip. Which brings us to what I think is the real question. When you stand in front of a mirror and see a left-right flip, you're not seeing a fact about the mirror. You're seeing a fact about you, about the specific spatial model your brain built, the specific conventions it uses to interpret facing bodies, the specific biomechanical history that made vertical axis rotation the default interpretation. The flip is real as an experience, it is constructed as a perception. And the gap between those two things, between experience and geometry, is where the interesting question lives. Your perception of space is not a neutral readout of physical reality. It's a model. Built by evolution, calibrated by experience, structured around the specific needs of an upright, bilaterally symmetric body moving through a gravitational field. That model is extraordinarily useful. It is also, demonstrably, not the same as the geometry itself. The mirror doesn't show you a reversed world. It shows you that your model of the world has a built-in orientation, an observer at the center, a facing direction, a preferred axis of rotation, and that the question left or right only makes sense from inside that model. Without the observer, there is no flip. Without the body, there is no left. The mirror is a flat piece of glass doing simple geometry. The puzzle is entirely yours. And the fact that a flat piece of glass doing simple geometry can reveal something that deep about the structure of human perception, that's the thing I find genuinely worth standing in front of a mirror to think about.